You need to render a list. Just a scrollable column of rows on screen. With a few dozen rows, the simple approach works perfectly. For every item in the data, you create one element in the page. The browser lays them out, the user scrolls, everything feels smooth. But now the list has 50,000 rows coming back from the server. The naive code loops over all 50,000 and builds a node for each. The browser now holds 50,000 elements in the document tree. Each one costs memory, layout, and paint, whether it is visible or not. The tab freezes for seconds on load, then scrolling stutters and lags. 50,000 nodes to show maybe 15. This is a nightmare. But look at the screen. Only about 15 rows are ever visible at once. The other 49,000 are scrolled far off, doing nothing but wasting memory. Virtual scrolling uses that. Only render the rows inside the viewport. First, give every row a known fixed height, say 40 pixels each. Multiply by the count to get the total height, and set one tall spacer. That spacer makes the scroll bar behave as if all 50,000 rows exist. But inside it, you only ever place the small handful that are on screen. Read the scroll position. Divide by row height to find the first visible index. From there, render just the 15 visible rows, plus a few above and below. Each rendered row is pushed down by an offset, so it sits in the right place. As the user scrolls, that window of indices slides across the data. Rows leaving the top are recycled to fill in at the bottom. Same nodes reused. The document tree holds about 20 elements, no matter how huge the list grows. 50,000 rows or 5 million. The render cost stays flat and cheap. Memory stays low. The first paint is instant and scrolling is buttery again. The user sees an endless list. The browser only ever touches what fits on screen. That's virtual scrolling. Render the visible window, fake the rest with height.